Section 2.7 in advanced geometry, starting out by recognizing some basic functions. Constant function is just a horizontal line because everything stays constant. Y never varies. That's what a constant function looks like. It's just a horizontal line. Linear function, even though a constant function is linear, when we talk about linear functions, it's any kind of oblique line. Can't be a vertical line because then it wouldn't be a function, right? These are all functions. So a linear function is oblique. A constant function is a horizontal line. Absolute value looks like a V, resistance graphical, and a quadratic function is a parabola. They ask us to recognize which one is. Out of these four possibilities, what is the constant, linear, absolute value, or quadratic? Linear, because there's no oblique line. That's a linear function right there. Next guy, number 2, working across. Out of those four things, who is he? An absolute value, because he looks like a V. And number 3, that is a parabola, correct? So that's called a quadratic. Please do the bottom 3 problems. So here we go on those 3. Pretty simple. Now, let me kind of preview what this purple note card is all about. There's 4 things on this purple note card. Step 1 wants to know if things have gotten reflected over the x-axis. Talk about a parent function. All those posters that I put up on the wall are called parent functions. They are the most plain Jane type of function around. Like this is a linear function, correct? And this is as plain of an oblique line as I can get. Y equals 1x plus 0. Isn't the slope 1 and the y-intercept is 0? That is the parent line, which is also called the identity function, as you see up there, because y is always equal to x. They are identical to each other. So if I reflect it over the x-axis, wouldn't this guy right here come down here, like that thing did, and wouldn't this part right here come up there? You see, if I reflect it over the x-axis, that's the number in front of x, with negative. Cool? If I reflect this guy over the x-axis, the number in front of x squared became negative, didn't it go from opening up to opening down? Now that? If I reflect the absolute value v, here's the parent guy, this first x is at 0, 0. If I reflect him over the x-axis, doesn't it just change the openness? Right, how it opens down. If I do a translation, that means I'm going to slide it left or right. So back to our original line right here. This parent point is always at 0, 0. We're very concerned about 0, 0. Check this out. I have moved that point 2 units left and 5 units up. 2 units left and 5 units up is where I have split it. But notice what happens in the function. When I move 2 units left, you would think that that would say minus 2. But it's plus 2. Because when you're in grouping symbols, it's the opposite of what's the name. And then you want 5 units up, what you see is what you get right there. Same thing here. If I move him 2 units right, that's what this guy did. Moved it from 0, 0 to 2 units right, and then 4 units up. Right, so that's what happened there. Translation here, where's this guy going to move? 3 units which way? Left or right? That says plus 3, so wouldn't you think right, correct? Where is it actually going to move? Left 3 units. Where's this guy going to move? Down 5. And that's what happens. The point 0, 0 moves 3 units left and 5 units down. So far, so good. Then I could do some dilation. That's some sort of vertical stretch or vertical compression. These graphs will probably confuse the heck out of you. I think it's easy to just use our hands. Okay? And what I do to use my hands is I just pretend that I have a big lump of wet clay in my hand. Okay? And if I say I want to vertically stretch it, wouldn't that mean that I would do this? Vertically stretch? What happens to that piece of clay? Does it get fatter or skinnier if I vertically stretch it? It gets skinny, correct? Now watch me take that same piece of clay and vertically compress it. Vertically compress means do that to it. What happens to it? Does it get fatter or skinnier? It gets fatter. You've done this in Algebra 1. What you have not done is any horizontal dilation. I'll take that same piece of clay and I will stretch it horizontally. So wouldn't that mean that I would do this? Horizontally stretch it, correct? What happens to it? Did it get fatter or skinnier if I horizontally stretch it? Skinnier. And if I horizontally, it got fatter. So it got fatter. And if I horizontally compress it, it gets what? Continuous, right? So you horizontally stretch, don't you make it fatter, right? You horizontally compress it, it gets skinny. Cool? So all the first 3 steps of this 4-step process are actually not new to you if you had Common Core Algebra 1, which I believe every single one of you did. It's the 4th step about this horizontal dilation. So all this stuff to me, you wouldn't have understood it if I showed you. Check out your purple note card right here. I will refer to it often as the purple note card. I have put a generic function on here. Realize this is not any kind of specific function at all. This is generic function. And I'm going to continue to look at these 4 places in particular. There is an A value on there, which I have the luxury of highlighting green. You are not allowed to write on your purple note chart, by the way. Okay, you do not write on it. Let's put your name and marker on it. The A value is in green, and please notice that he is outside of grouping. Right? You see there are parentheses. Those group symbols could change. They could turn into absolute value bars. They could turn into square root symbols, right? Any kind of grouping symbol that we've been familiar with. A value outside of grouping symbols. The B value is inside the grouping symbols, but it is right in front of X. With me on that? Then there's this minus H and this plus K that we have in blue and pink right here. 4 steps, 4 things to look at right here. So here's the 4-step process. They asked us to first, let's identify who the parent function is on number 7 right here. What kind of graph is this? Out of all of that stuff up there, identity, parabola, cubic, hyperbola, inverse square, square root, absolute value, exponential, or greatest integer of the step, what does this guy look like right here? He is what kind of graph? He's an absolute value. So let's say who the parent function is. The parent function, you have to do this, is y equals absolute value of x. That's like where this guy came from. This is the plain Jane absolute value function, which looks like this. Don't sketch it, but doesn't it look like this? Correct? It opens up, and its vertex is at 0, 0. Correct? Do not sketch that thing. What we're going to do is realize how does this new function right here relate to this one with a 4-step process. And it just takes a little bit of time. I'm going to get my highlighter out and highlight those 4 places. You don't have to highlight. By the time we're done with this worksheet, it will be pretty simple. But there's 4 places to look at. A green place, a red place, blue place, and a pink place. They want to know, step 1. Remember, you did use this note card, and it tells you exactly what to do. Please remember 4 steps down the side of this puppy right here. And we're going to answer 4 steps. Real simple. And the first step to answer is right here. They want to know, did this graph get reflected over the x-axis? Well, how you tell is you look at the A value. According to my highlighted function, isn't the A value the green number, which is in front of the grouping symbol? I have it highlighted green also over here. The number in front of the grouping symbol. What is that number in this case? It is what number? That's not a 0. It is what? 1. It is a 1. And there's not a number there. There is a 1 there. Cool? All you look at is if that is negative. Is that number negative? Yes or no? So did this graph get reflected over the x-axis? Yes or no? It didn't happen. It will get reflected if that's a negative number. This is a positive number. And I was even asking you that last class period. I was like, hey, will this thing open up or open down? What would you say? Open up or open down? It opens up. Doesn't the parent guy open up? And so will this guy. And you know why? Because it did not get reflected over the x-axis. So step 1, you're only looking to see if this green thing is negative. It is not. So we put a dash there. Please put that dash there, meaning it didn't happen. Step 2, you look for a translation. The translation is HK. You see H is the blue thing, and K is the pink thing, correct? But in your function, doesn't the H have a negative symbol in front of it, correct? That's why it's the opposite of the blue thing and the pink thing. Who is our blue number right here? It is 1. That means that this thing gets translated. We'll put a giant capital T for translation. If that's a +1, that means it got translated 1 unit left. The opposite of what you think right there. Why left? Because isn't that hanging out with X? There's an x go left and right on your graph, correct? So opposite of what you think right here, so put a -1. And then how far did it get translated up or down? Is it +7 or -7? +7. What you see is what you get. It's the opposite of this guy that's in the group, and what you see is what you get with that one. Cool? So what happened now is my absolute value B, its vertex was at 0, 0. Now it's got to move 1 unit left and 7 units up. Won't that vertex be up there now? Correct? You with me on that? Now we want to see if this thing got dilated. Did it get fatter or skinnier or anything like that? Right? That's dilated. That's step 3. And what you got to look at is 2 things now. You have to look at the A value, which is the green thing, correct? And you have to look at the B value, which is the red number, the number in front of that. So let's do one at a time. Vertically stretched, has to do with green stuff. The A value, you see how they're talking about A values right there. If that A value, when you think of him as positive, that's why I've got absolute value bars around that A value. Just think of the A value as a positive number. If he's bigger than 1, this graph will get vertically stretched. But if that A value is between 0 and 1, it'll get vertically compressed. Now if that A value actually is 1, then it will stay the same size. So 3 things to think about. Are you bigger than 1? Are you less than 1? Or are you 1? Here's our A value. What is it? It's 1. Did this get any kind of vertical dilation to it whatsoever? No. Then you have to check for horizontal dilation. Doesn't that have to do with your B value right here, correct? The B value is the red number, the number in front of X. Again, if the B value is bigger than 1, this will get horizontally compressed. If the B value is between 0 and 1, it will get horizontally stretched. If the B value is 1, then nothing happens to it. It stays the same size. What's my B value? 1. Was there any horizontal dilation whatsoever? So nothing happened vertically, nothing happened horizontally. So far so good? The last thing you look for is to see if it got reflected over the y-axis. That's step 4. And how do you tell if it gets reflected over the y-axis? Again, that has to do with the B value, which is my red number, correct? All you're looking at to see if that's a negative number. Is my B value a negative number? Yes or no? No. So that means it did not get reflected over the y-axis. The only thing that happened is this absolute value B was it got translated 1 unit left and 7 units up. It did not get reflected over the x-axis. It did not get fatter or skinnier either which way, and it did not reflect over the y-axis either. So they asked you then to make a little sketch of it. I want you to think again. How will it open? Up or down? Up. Where does the vertex move? -1, 7. Put it, and you must put that ordered pair of -1, 7. Did it get fatter or skinnier at all? Right here. Did it get fatter or skinnier at all? Just a no. So you make this, it's just a sketch, you make this a normal size with a normal absolute value. And did it get reflected over the y-axis? No. There's our sketch. And all that did was help us answer the question. We haven't even answered the question yet, because they want us to write a sentence. Ladies, gentlemen, how do you sentence start? Capital letters, and how do they end? With a period. Takes time to do it right. Every sentence will start the same way. The graph of, I'll get you started. The graph of. The graph of. And then who was our parent function? We have already written down who our parent function was. Who was our parent function? Y equals absolute value of x. The graph of whatever our parent function was has been. And then that's how every sentence will start. Note, this will change based on who your parent function is. Right? The graph of whoever we've had to start with has been. Then we put this stuff in there. Was he reflected over the x-axis? Yes or no? No. So we don't mention anything about this. Was he translated? Where was he translated? 1 unit left and boom. So the graph of y equals absolute value of x has been translated. 1 unit left and 7 units up. And nothing else happens to it, so you put a period in here. And it takes a little while to get used to this, That's why we have tons of examples we go through today. But the graph of y equals absolute value of x has been translated 1 unit left and 7 units up. Let's look again. The most important part is you got to have your sketch, and you must tell me where the point 0, 0 has moved to. It is at -1, 7. Cool? So, realize this will make life a lot easier if you could look at a function and see what it kind of looks like without even having to punch in and graphing calculus. So, only one example. Let's try it again. Identify our parent function first. This is our parent. Who is he? Y equals absolute value of x. Because this guy has absolute value bar, our parent function is the absolute value function. Cool? Then, you always got to think of them, and I won't lie to you, I will cover those up on test day. Like, you've got to know what they look like in your brain. Okay, so what do they look like? So, doesn't it look like a V that opens up? Normal. Correct? First thing to look at. Again, I'll bring my highlighters into play. Red, green, red, blue, and pink. Step 1, reader. What are we looking for? You have to do this on your own. You have 4 steps. What's the first thing we look for? It can't get any easier when I literally type it out, right? You're looking for a reflection over the x-axis. How do you tell? You look at the a value. Where's the a value go? He's the green number, correct? Is he inside grouping symbols or outside grouping symbols? Outside. Is there a number outside my grouping symbols, yes or no? And all I care about is if that number is negative. Is that number negative, yes or no? So, did he get reflected over the x-axis? The way I write that, remember back in geometry where we did reflections, we use a little r, and then we'll put a subscript of s. It got reflected over the x-axis. So tell me what that means. What's going to happen to this puppy? He normally opens up. Now what will our sketch look like? It's going to open down. Cool? Second thing to look for is translation. That's HK. Isn't that blue pink? Correct? Blue is a -3. Always put a capital T. I've got it typed for you right here. You'll put a capital T, and then you put the H value and the K value. The H value is not -3. What's the H value? We're going to make it +3. And then the K value is -7. What does it mean? That this thing translated 3 units where? To the right, and 7 units down. So far, so good? Those are the 2 easiest parts of this deal. This stuff takes a little time to get used to. You've got to look at 2 things. Vertical stretch or vertical compress, you're looking at A again. But you think of them as a positive number, right? That's why it's got absolute value bar. The A value is really 1, right? That negative has nothing to do with the A value. It has to do with if it gets reflected over the x-axis or not. So, is the A value bigger than 1, between 0 and 1, or actually 1? It's actually 1, correct? Was there any kind of vertical dilation? Nope. Still doesn't mean we're done with the dilation part. We got to check for horizontal dilation. We're looking at the B value, which is the number in front of X inside the grouping symbol, which isn't that a 1 in this case, correct? Was there any horizontal dilation? No. So good for us. Nothing happened. Then you look for reflection over the y-axis, which is your B value again, which is the red number, the number in front of X. All you care about is if he's negative. Is that number negative? No. So it did not get reflected over the y-axis. So let's make our sketch. We start at 0, 0 for our vertex, correct? And you need to think, should this open up or should this open down? Down, based on step 1, correct? Where did the vertex move to? 3 units right and 7 units down. Rough sketch, put that ordered pair in there. And notice where I placed the ordered pair, I put it above that dot. Because where's my thing opening? Down. Did it get fatter or skinnier at all? So the same rough sketch of your absolute value B. So far so good. Now we write our sentence. Starts with the graph up. You will get very tired of writing the sentence and stuff. The graph of whoever our parent function, in this case it's y equals absolute value of x, has been reflected over the x-axis, and translated 3 units right and 7 units down. You write them in the order of the 4 steps. Whatever step 1 is, if there was something there, you put it in your sentence. Something in step 2, put it in your sentence, etc. So we have already identified our parent function here on number 9, if y equals x. The first thing I look for is to see if this gets reflected over the x-axis or not. And you know, that's tricky for people on 1.6 because there are no groupings. But you can put them in there. They're right there. There's the grouping. So let me do my re-highlighting trick right there. I will highlight the green because isn't that in front of the grouping? Correct. I will highlight the red number, the number in front of that inside the grouping symbol. I will highlight the blue number. There really isn't one. And I will highlight the pink number. It's so easy that it's hard. Because people are like, how do you know if that 3/5 is inside the grouping symbol or outside the grouping symbol? Let me ask you a question. Did they put it inside the grouping symbol to start with? Then it's not inside the grouping symbol. You will literally see it inside grouping symbol if it's supposed to be inside grouping symbol. So 3/5 is the A value because it was not inside grouping symbol to start with. Did this graph get reflected over the x-axis? Yes or no? No. Why not? Tell me about 3/5. Why didn't it get reflected? It's not a negative number. Well, it's a positive number. Translation. You will always put something into translation. Even if it doesn't move, you would say it got translated 0, 0. Cool? So, did it move left or right at all? I look at the blue number, which is supposed to be the number inside the grouping symbol hanging out with x. Was there a number inside the grouping symbol hanging out with x? Because a lot of people ask that about that 4. It's like, how do you know if that +4 is inside grouping symbol or not inside grouping symbol? Did it put it inside grouping symbol? No. So it's not inside the grouping symbol. So where did it get translated? Left or right way? 0. How about up or down? Did it move up or down? 4 units up. Cool? You good with that? Then, dilation time. Vertically is about the green number, correct? If the green number is not 1, there was some vertical dilation. The green number is 3/5. So there was some vertical dilation. Is it stretched or compressed? You look at what I typed out for you. Is 3/5 bigger than 1? So it did not get vertically stretched. Didn't get vertically compressed. So I'll let you do this for abbreviation. It got vertically compressed by a factor of, what was the A value? 3/5. So it got vertically compressed by a factor of 3/5. This graph got vertically compressed by a factor of 3/5. It will not have the parent slope. Wasn't this a line? Isn't the parent slope rise 1, run 1, rise 1, run 1? This one's rise in 3, run in 5. Rise in 3, run in 5. It got vertically compressed a little bit. Okay? And then was there any kind of reflection over the wire? What color of thing am I looking at in here? Green, red, blue, or pink? What do I look at? Green, red, blue, or pink? Red. And I'm looking to see if that red thing is what kind of number? Negative. Was it negative? No. So, let's make a sketch. It normally starts at 0, 0. It's now going to be at 0, 4. 0, 4. The point 0, 0 has moved to 0, 4. Did this thing get reflected over the x-axis or not? Yes or no? So do you know which way a line normally goes? This way, correct? It will still go that way. The thing is, the slope will not be 1, it will be 2, 0. And now write this down. The graph of whoever our parent function is has been. The graph of y equals x has been. Now let's do the rest together. The graph of y equals x has been. What do you want to say next? translated 4 units up. I don't need to say 0 units right. Okay, just say 4 units up. Graph of y equals x has been translated 4 units up, and what would you say next? What kind of compressed? There's all kinds of compressed. It's been vertically compressed. Please spell it correct. Hey, it's right there on your card, what you'll have, spelled vertically correct, has been vertically compressed by a factor of 3/5, period. The graph of y equals x has been translated 4 units up and vertically compressed by a factor of 3/5. Still, only 3 examples. Cool? Getting warmer. I don't know if this helps you or not. It helped the other day when I did this in a different class. Green, isn't that the number in front of the grouping symbol? Red. Blue, is there a blue number? The blue number is inside the grouping symbol, there is none. And pink. Cool. Who's our parent function in this bad boy? Parent, y equals x squared. You see the squared on the outside. Right? Let's see if this thing, you normally know what it looks like. It doesn't even look like this. It's a parabola that opens up to the vertex is 0, 0. Isn't that up here? Let's see what it'll look like now. Did it get reflected over the x-axis? Yes or no? How do you know? Which color did you look at? Green, the A value, right? And you look to see if it was negative. It is not negative. So it did not get reflected over the x-axis. Translation. You will always put something in step 2. Blue, pink, right? Opposite of blue, pink. What was our blue number? 0. Pink is -8. What does it mean? That thing got translated 8 units down. Cool? 3, dilation. Looking to see if the green number is 1 or not 1. Is the green number 1 or not 1? It's 1. No vertical dilation. Horizontal dilation. Looking at the B value. Thinking of it as positive, right? Thinking of it as positive. Do you realize that that's what absolute value means? Think of it as positive. Even though that B value is a -1, think of it as positive as a 1. Was there any horizontal dilation? No. Nothing happened there. One more thing to check. That it gets reflected over the y-axis. You look at the B value, and if he's negative, it happens. Did that happen here? So, got reflected over the y-axis. Now let's see what happens to this graph. Cool? First, I want you to think about how it opens. Up or down. It's going to open up. Then we need to move our vertex. Doesn't the vertex normally start at 0, 0 of the parent function? It moved 8 units down. So let's put it right there. But it's going to move again because didn't there happen to have some reflection. The thing is, how far will it move? But before we move it again, think about fat or skinny. Does that change? No. Now I have to take this point and reflect it over the y-axis. And in this case, it won't move. Why not? It's on the y-axis. It won't move anywhere. But if that point was somewhere else, like if it was over here, then you'd have to move it over here. You see how I moved it and reflected it over the y-axis? So we'll see that here in a second. But it didn't move because it was actually on the y-axis. Rock and roll? So now let's make our sketch. This point is at 0, -8. And the parabola, fatness or skinniness, right, stayed the same. And which way did it open again? Up. So watch me make a mistake. What mistake did I make? I did an absolute value, okay, when this should have been a parabola, correct? Normal parabola. Let's see what you write here. Here's our sentence. Now what I'd like you to do is pause the video, try number 11 with a foul. Hopefully you're watching the video with a foul. Try this one on your own. Our parent is y equals absolute value of x. First thing I want to know if it gets reflected over the x-axis. Yes or no? What do you think? The answer is yes. Where did I see that at? Right here. Isn't it that guy? Right there. Correct? Next thing I want to know, translation. You'll always put something. Looking at him, what will I put? 4 or negative 4? And then it goes to negative 3. That's probably the easiest part of all four of these things. I don't know. That's my opinion. Dilation. Was there any kind of dilation? Was there vertical dilation? Yes or no? Vertical is about A, correct, which is green. And then he's the A value, like that. So, since he's not 1, there was some vertical dilation. Did he get vertically stretched or vertically compressed? Remember, you don't think about the fact that that's a negative 1/2. You only realize that he's a 1/2. What does the negative have to do with? Step 1, right? That's all the negative part has to do with. And absolute value. Think of the absolute value of negative 1/2. Is that 1/2 bigger than 1? No. Is 1/2 between 0 and 1? Yes. So we got vertically what? Compressed by a factor of 1/2. Did it get horizontally compressed also? And I won't do that to you. I won't give you a graph that's been vertically dilated and also horizontally dilated. That's just me. Because it's like, how the heck would you make a sketch of that? You know, it's like this way, and then it went that way. It's like, what's going on? So I won't do both dilations to you at one time. The last question, though, is did he get reflected over the y-axis? Yes or no? And that has to do with him right here. Correct? That is negative. So it did get reflected over the y-axis. Groovy? Let's make a sketch. Doesn't even look like a V, right? How will he open? Down. Let's move our vertex. It moves 4 units left and 3 units down. So that's blue points, correct? But then you got to kind of jump over and realize, hey, bro, doesn't it get reflected over the y-axis also? So where should the blue point go if I reflect them over the y-axis? Should it become into green? Or should it become into red? Which one got reflected over the y-axis? The red one, correct? So where would that be at? If it helps you to put this point is at negative 4, negative 3. I put that order pair. Now I need the red point. Where is that at? Is it at negative 4, positive 3? Or is that negative, is it positive 4, negative 3? You can just think about it. That's at 4, negative 3 still. If you reflect over the y-axis, doesn't your x value change? So here's our real vertex of our absolute value v, and it got vertically compressed by a factor of 1/2. Feel free to use your hands. Like, what happened to it? Vertically compressed. Fatter or skinnier? What did it get? It got fatter. So think about how you would normally make your v, and then make him fatter than that. And which way is it open again? Fatter. Yep, fatter. Like you took him and vertically compressed him, made him fatter. Then write your sentence. Let's wrap up. Awesome, we got all 4 parts to write down. Nice, neat, long sentence. So here's our sentence on the previous one. Graph of y equals absolute value x under factor of factors, translate towards the plus down. First, the plus by a factor of 1/2. Make sure that's a positive number, not a negative. A value 0, 1/2. Now try to use 4 steps. Get the check back with me. I'll check you in. Did he get reflected over the x-axis? Yes or no? Nope. That is this number right here. Positive. Translation. Did they add or subtract anything inside the parentheses for x? Nope. Did he move up or down at all? Down 2. Go with those 2. Dilation time. Vertical dilation is all about A. A is green. A is green. Correct? Yes. Was there any vertical dilation? Yes or no? No. Horizontal dilation. It's about B. C is the number in front of X inside the parentheses. It is 1. So there was horizontal dilation. And a lot of people would say horizontally compressed by a factor of 4. And I wouldn't blame you. But that's where we make our tiny mistake. Because is there something happening to that 4? Yes or no? It's got to get squared. So you got to take the 4 and do whatever exponent it is. If that was the first power, you'd still have a 4. If that was the third power, you'd have a 64. Come shoot out of it. What shoots out of this? 4 squared is. So this got horizontally compressed by a factor of 16. That's the tricky part. If you had 4, can't blame you. Right? We didn't talk about that yet. Horizontally compressed by a factor of 16. And then finally, did he get reflected over the y-axis? Even though that's 4, we just look at him and see if he's negative. If he's not negative, it didn't happen. We're cool with that. Make our sketch. This is a parabola that will open up and move 2 units down, correct? So, there we go. It didn't get reflected over the y-axis, so I don't have to worry about moving that guy again. And now I just got to make my sketch, after I put my ordered pair, horizontally compressed. Use your hand. Horizontally compressed. What happens to it? Fatter or skinnier? Skinnier. A lot skinnier. So didn't we do it by a factor of 16? Like 16 times skinnier? So mega skinny. Mega skinny. Cool? Check this out. Horizontal compressed. Same thing as vertical stretch. Right? Vertical stretch. Same thing. If you vertically stretch something, it's the same thing as horizontal compressed. And then finally our thing. The graph of y equals x squared has been translated 2 units down, horizontally compressed by a factor of 6. So on our last problem here, why don't you go ahead and try the whole thing for yourself. Pause the video, get it done, check back with me here in a second. So on the last one, the graph of y equals x squared has been reflected over the x-axis, translated 5 units right and 3 units up, and vertically stretched by a factor of 2, so it should have got 2 meters. Twice as much. That other one got 16 times as big. With the purple note card, it shouldn't be that big of a deal. Right? With the purple note card by your side, follow the 4 steps. And now let's do the whole thing backwards. They tell me who the parent function is. They tell me what happens to it. Let's write his equation. Okay? So what I'm going to do is I'm going to start with my parent, and I'm going to give myself space. I know stuff's going to happen to it. Right? So it's my parent function. I left space for an A value. I should have left space for a B value. My bad. I need to leave a little bit of space for a B value. Okay. I left space for an H and a K value also. Doesn't mean they're all going to be there. So let's just read. And they kind of give it to us out of order sometimes too. They should do it in the order of our 4 steps, but they like to make things around. So it's been translated 3 units to the left. Where would that go? Let me give you some colors here. Green, red, blue. Okay. Where does 3 units left go? Blue. And what do I put in there? Plus 3. Plus 3. Then I cross them out. Cross them out. Like, dude, I've used you. Right? I did the 3 units to the left. So I want to make sure I've done everything. 4 units up. What position would I put him in color-wise? See? And would I put plus 4 or minus 4? Plus 4. Cross them out. Reflected over the x-axis. So what does that affect? The green thing or the red thing? Green. And what would I put in there? A negative. And vertically stretched by a factor of 7. Should I put that in the green spot or in the red spot if it's vertically stretched? green. Let me just put that 7 in there. So there was no number to put in for red, it's just a 1. And just follow the thing, cross out what you've done, and set it up generically. 2, no.